Good morning, students. We started the first order linear differential equations last time. We didn't have time to do an example, so we shall do that. And then we shall move on to Bernoulli equations and finish first order differential equations. Okay, there is one more form that we need to do, but that requires partial derivatives. So we shall do it after we cover that. Okay. First order linear differential equation. An equation, the equations of the form dy over dx plus px times y equals qx. Try to understand the form first. Dy over dx. We did several other forms earlier. So separable equations, then f of ax plus by plus c type dy over dx equals, and then we did the homogeneous equations, and then now first order linear differential equation, fourth type. And derivative, this is y dash or dy over dx, a function of x times y equals a function of x. How do you solve such equations? Linear differential equations come up in various applications. So try to understand it well. Method of solution. For linear differential equations, we associate something called integrating factor. That is, e to the integration is here, okay, upstairs. Integral this function dx. Okay, that we shall denote by ix, integrating factor, ix. It's a function of x now. After integration, you get a function of x here. Integrating factor. After finding the integrating factor, you take the equation and multiply this by the integrating factor. Something beautiful happens when you do that. So ix dy over dx plus ix px y equals ix qx. So first form the integrating factor, okay, and multiply equation 1 by that. This is what I just said. Take the equation, multiply. This side always becomes, using the product rule, integrating factor times y. Check that. Derivative of a y is also a function of x now. Differential equation. We are solving for y. So we have to use the product rule. First one times derivative of the second. That is this term. Plus first one times derivative of the second, plus second one, that is y times derivative of ix. Derivative of ix, here I have done that. Derivative of ix, ix is e to the integral px dx. No? So if I take the derivative, we know exponential derivative is the same multiplied by the derivative of the function at the top, chain rule. So it's e to the something. If it had been e to the x, answer is e to the x. Now this is e to the something else. So the derivative is e to that multiplied by the derivative of this function. d over dx integral. Now here, derivative of an integral. These are the collection of all antiderivatives. No? So when you take the derivative, you get the function back. P of x. D over dx integration and differentiation are reverse processes. Okay, so when you apply the derivative to an integral, you get the function back, ix px. So that is how this part is, that part is the same as d over dx, d over dx, ix. Don't worry, when we do an example, everything will become clear. So now, these two terms together gives us that is equal to this. Now, derivative is equal to this. So integrate both sides. If you integrate a derivative, I just said integral and the derivatives are reverse processes, inverse processes if you want it that way. So when you integrate this one, you get integral of this side is ixy equals integral of the other side. So this is a function of x. After integration, you get the answer. So y is equal to that divided by ix. So if you can come up to this place, you can find y. So that is the method of solution. Now it's a complicated sounding thing. So let us do an example, okay? To solve first order linear differential equations, okay? So first example, we will do a few. X dy over dx, x dy over dx minus 2y is equal to x cubed e to the x. Now, when you see this equation, you should recognize it as a linear differential equation. Now, you might say, in the equation, we have dy over dx now. But in the given one, it is x dy over dx minus 2y equals this. So, the first thing to do is make this into this form. How do we turn this equation into this? What should we do? You have to divide by x. Okay, divide by x. When you divide by x, this equation becomes dy over dx. So that is this term divided by x minus. We have to divide this also by x. Every term should be divided by x. So second term becomes minus 2 over x y equals, you are dividing this by x. What do you get? Just to make sure that you are following.
X squared e to
X
the
squared
power.
e to the x. Very good. X squared e to the x. Now these two are of the same type. So this is a linear first order. This is a first order linear differential equation. First order y, only the first derivative is there. First order linear, they are called linear differential equation. First order linear differential differential equation. It's a first order linear differential equation. So how do you solve? The method of solution, first form the integrating factor. What is the integrating factor? Integrating factor is e to the integral px dx. So form the integrating factor. And then multiply the equation by the integrating factor. So if integrating factor, if we call it ix also. If integrating factor, let me write it in words. Integrating factor, What is the integrating factor? Integrating factor is e to the integral, sounds complicated. E to the integral, what is p of x? P of x is what you have here. Integrating factor is equal to e to the integral p of x. P of x is minus 2 over x dx. This is P of x. E to the integral P of x dx. Now what is the answer? This is equal to, you can take the minus 2 out. You can write the answer straight away. Minus 2 out, integral, think of it as, so e to the, this is the integral part, 1 over x dx. What is the integral 1 over x dx? E to the px dx. This integral is, yes, what is integral 1 over x? E to the minus, yes, very good. Ln absolute x. Absolute value is there. Now, this can be simplified. This minus 2 can be taken here, no, for ln. This is equal to e to the ln absolute x to the power minus 2. Absolute x to the power minus 2. E to the ln absolute. So we are just doing integrating factor. Now this is equal to e to the e and ln. They kill each other. This is equal to, this is log e base now. This is e. That is equal to absolute x to the power minus 2. That is the same as 1 over absolute x squared minus 2 power. When you square, you don't need the absolute. 1 over absolute x squared, which is equal to 1 over x squared. So integrating factor, okay, you don't have to write this many steps. If you can straight away integrate and say from here, you can straight away come here and then write it here, take minus 2 there and simplify. E and ln nearby, cancel the effects. You get the function back there. So absolute x squared, absolute x is x if x is greater than or equal to 0, minus x if x is less than 0. So, but when you square, whether it is plus or minus, we will get x squared. So integrating factor is 1 over x squared. Now go to the equation. Let us call this equation the first order type, equation 1. Now, what is the method of solution? Take the equation and multiply by the integrating factor. So 1, I have to multiply 1 by the integrating factor, which is x squared. What is the equation? For easy reference, let me write that again. What is my equation now? Dy over dx minus 2 over x dy over dx minus 2 over xy equals x squared e to the x. You may not remember, so let me show you. This was a given problem. Dividing by x, we got this equation. So after that, we found the integrating factor. Method is to multiply this equation by the integrating factor. Multiply. So this is our equation 1. Integrating factor is 1 over x squared. So multiply 1 by 1 over x squared. So what do we get here? 1 over x squared dy over dx minus, what do we get here? 2 over x multiplied by 1 over x squared. So what is the term here?
2 over x cubed.
2 over x cubed. Very good. 2 over x cubed. Y equals, what is on this side?
E to the x.
E to the x. X squared and 1 over x squared cancel. So e to the x. Now we said this side, after you do that, this side is always equal to d over dx derivative of integrating factor times y. Integrating factor of ix times y. That is equal to e to the x. So this step need not be written. You can straight away write d over dx. What is the integrating factor? Integrating factor is 1 over x squared. 1 over x squared, 1 over x squared y. It magically happens like, no? E to the x. Now take the derivative and see. Take the derivative of this. 1 over x squared times derivative of y. dy over dx. That is this term. And y times, or here y, times derivative of 1 over x squared is x to the power minus 2. No? Derivative is minus 2 x to the minus 3. That is what is minus, this is minus 2 x to the power minus 3. So it always happens, okay? We proved that in the theory. No? So now you can straight away use it without any explanation. Okay? Now, next thing, now derivative of this is equal to that. So this must be the integral of this. So integrate both sides, therefore 1 over x squared. So maybe we shall put an integral sign. Integral sign, integrate this equation. When you integrate a derivative, you get 1 over x squared y. Okay, that is this side, integral of this side equals integral e to the x dx. Integrate both sides. These two are equal, therefore integrals are. When you integrate a derivative, you get the function, what's inside the derivative back. Equals integral ex dx. What is integral ex dx? Yes? Integral of e to the x is the simplest one, e to the x, then put plus c. Plus c. Now, x squared. Therefore, y is equal to multiply by x squared. X squared e to the x plus, or if you want, you can put a bracket, or plus c times x squared, where, what is c? Where c is an arbitrary constant. Arbitrary constant. That is the solution. Okay, we have found y as a function of x. First problem. Let us do another one. Again, review the theory. If an equation is of this form, dy over dx plus a function of x times y equals a function of x. This p and q are like f of x, g of x. First, go to this piece and form the integrating factor, e to the integral px dx. So integration is done here, nothing to do with this. Integrating factor is e to the, so integrate that and find the integrating factor, then multiply the equation given by the integrating factor. Left hand side is always integrating factor times y. So when you integrate this side, you get this equals integral of this side. And then that is what we did in the previous problem. Now, let us do another example. Again, example, another one. These are standard, it's algorithmic type. No? Second example is x, let me write it as xy dash plus y equals e to the power x subject to this condition, subject to y1 is equal to 2. subject to y1 is equal to 2. Now, you know, in the previous problem, there was a c there. No? So if you have a condition like this, y at, I need the solution with y1 is equal to 2. These type of conditions are called inertial conditions or boundary conditions here. Doesn't matter. Subject to this condition. So after solving, you have to use this to find the constant. Okay, so first of all, forget this for now. Look at this equation. This is not exactly the way the equation was linear, first order linear differential equation was written. Again, there is something with dy over dx. So divide by that and make it into this form. That is the first step. Previous problem, it was x squared, now x. So first divide by x. Divide this equation by x. What do you get? So y dash plus
1
1 over x y equals 1 over x times e, or e to the x over x. Now this is of the linear first y dash, meaning dy over dx. We have to get used to that also. So this is dy over dx. So p of x now is what? P of x is this, y dash, meaning dy over dx plus pxy equals q. What is px? Y dash dy over dx plus pxy equals qx. This is like p of x, this is like q of x. We need to first identify p of x. So now we are first thing, integrating factor. Let me write if, or ix is also okay. Integrating factor is equal to, how do you find the integrating factor? E to the integral p of x, 1 over x dx. And now tell me the answer. What do you get?
e to the ln absolute x.
E to the ln absolute x. Now, e to the ln absolute x. Now what will happen? E and ln kill each other. So what is the solution? This is equal to
X.
Yes, absolute x. Absolute x. But if x is now, consider take so there are two cases, no, x positive and x negative. Here y of 1 is given to be 2. So I need the solution where y1 is positive. Okay, 1. So if I have the solution for x greater than 0, it's enough. So if I take this is equal to x for x greater than 0. So integrating factor is x now. Understand it? Now what do? We go to the equation 1 and multiply 1 by the integrating factor. 1 multiplied by if. 1 multiplied by if. That gives me, take this equation and multiply by x. So what is this here? X squared y dash. I'm using y dash for dy over dx, since I want you to get used to that also. Plus, what is the next term? Multiply this equation by the integrating factor, x. So, first term is, where did I get x squared? No, this one by, so this is wrong. This is just x. xy dash. I have to multiply this. So it comes back to the original equation. That's okay. That's okay. We need to identify the integrating factor. So xy dash plus, what do you get?
Y.
Y equals
e to the x.
e to the x or x e to the x. I have to multiply, yeah, e to the x, sorry. This one, I was looking at this, so you might also make the same mistake. Make sure that you multiply by the standard form, okay, by the integrating factor. So x, y dash. So we are back to the original equation. It was, but we know when we do this, this side is equal to what? D over dx integrating factor. If you can observe that then and there, then you could skip this and just write this. But d over dx integrating factor is x times if times y. X times y is equal to e to the x. Okay, we went roundabout way to write this because we might not recognize it just by looking at it. So now try this one times derivative of y, sorry, x times derivative of y, that is there. Then y times derivative of x is 1. So that is that. It always happens. So this is equal to e to the x. Okay, this is the original equation. So this is the given equation. But now we understand it as the given equation, in fact. So if you can just by looking at this say it is this, some students do. Then you don't have to have the integrating factor. It doesn't matter, no? What we want is to solve. So, but our standard procedure gives you this. Now, integrate both sides. If you integrate both sides, what do you get? Integral of this side is integrate both sides. Integral of this side is just x, y equals this side, put the integral sign e to the x dx. So this is equal to, therefore xy is equal to e to the x plus c, where c is an arbitrary constant. Now, what is the given condition? Now go to the given condition. Use use y at 1 equals 2. Y at 1 equal, y is a function of x. Okay, you can see that now. So here, if you want, you can write y as e to the x. So why don't we write that also? Therefore, from this we get, therefore, y is equal to e to the x over x plus c over x. Divide by x to find y. Now we have found y. Y is a function of x, where c is an arbitrary constant. Now we use y1 equals 2. You can use it on this also. Doesn't matter. You can find c. And after that, divide by x to find y. Or do it here. So now use this. Y, put x, now take this. Put, how do you use this? You now use this means put x equals 1 in this. Put x equals 1 in this. Y when x equals 1? Y1 equals 2. Y when x equals 1 is 2. 2 equals, put x equals 1. E plus C. E plus C. Therefore, C is equal to, take this e to the other side, 2 minus, therefore, C is equal to 2 minus E. 2 minus E. E is bigger than 2, that's okay. So this number is negative. Now go back to the equation and put the value of C. Therefore, now go to this. Therefore, what is y? Y is equal to e to the x. We can we can even keep 1 over x outside. Doesn't matter. E to the x over x plus what is c? C is 2 minus e. So value 2 minus, it's a number, 2 minus e over x. Therefore, this differential equation subject to that condition gives us how many solutions? Just one solution, unique solution is there. Okay, this is the solution. No arbitrary constant anymore. This is the solution. Okay, so that is how you solve a differential equation with a condition attached to it. Okay, here you might get confused. Y equals this. So when I put x equals 1, now y is a function of x. So when x equals 1, we were told that the value of y, 1 meaning, bracket 1 meaning, value of y when x is equal to 1 is equal to 2. So when I put x equals 1 here, there is no x to be seen in this. But when you put x equals 1, it is the same as saying y1. y1, and here also we put 1. Okay? Do you understand it?
Excuse me, sir.
Okay. Yes, sir.
Excuse me, sir.
Yes. So could you explain the integration factor again in this question, sir? Okay. The student is asking, what is the integrating factor? Integrating factor, you can write it down, dy over dx equals, if the equation is of this form, p of x times y equals qx. If the equation is in this form, that is what a first order linear differential equation is. Dy over dx plus the function of x attached to y. P of x times y. That P of x part is the part to be identified to find the integrating factor. Integrating factor is e to the integral of this function. Integral px dx. So that is if or ix. Integrating factor is this. So now for this particular problem, integrating factor for this problem, this is not the standard form of a first order linear equation. We learn how to solve this equation. So turn this equation into, if there is something with the derivative dy over dx, divide by that, and then you make the coefficient here as in the standard form, y dash dy over dx plus this 1 over xy, divide this also by x. So this equation becomes this one. Now this is a first order linear differential equation. This is our p of x in the standard form, that is p of x. This part is q of x. But for integrating factor, I need only p of x. No, integrating factor is e to the integral 1 over x. P of x is 1 over x dx. That is ln absolute x. The e and ln cancel, so we have absolute x. But for the given condition, we need the solution for x equals 1. X equals 1. So x positive is enough. That is why I went from here to here. Okay? When the absolute x is there. Otherwise, you have to consider two cases. X greater than 0 and x less than 0. Why? We divided by x here. No, so x cannot be 0 in this equation. Okay? X cannot be 0. So, so we pick the absolute. Suppose this was given to be y minus 1 equals to then we have to take minus x. But it doesn't matter because whether it is plus x or minus x, when you multiply all throughout, okay, all throughout, if minus is there, minus is there, minus is there, it becomes, so after you get this one, it's okay to consider only one. Okay, but I don't want to do the mistake of writing this as ln x. It's always ln absolute x. After coming here, either you can just pick the integrating factor to be x, it would be x or minus x. No? So whether x or minus x, when you multiply the whole thing, you get only x there. But here I explained it using the given condition that also must be taken into consideration. So even if x is negative, you would get minus x here. If you multiply this whole thing by minus x, minus cancels. You just get multiplication by x. So do you understand the integrating factor? Okay, after that, you take the equation 1 and multiply by the integrating factor. Left-hand side is always integrating factor, which is x times y. Derivative of that equals ex. Now integrate, d over dx disappears after integration, the derivative. So this is an antiderivative. Now integral of an derivative is the function. So xy, you might say the constant you don't have to put, wait till the thing is done. Integral of this side, that is it. So, okay. So is that the question you asked? The student wanted to ask a question. Are there any other questions?
Excuse me, sir.
Yes.
Sir, would me x for x greater than 0 කියලා දැන් මේක පහළ answer එකට දාන්න.
මෙතනද?
ඔව්.
ඔව් ඒක තමයි මම අර මෙතන තියෙන condition එක තියෙන්නේ x එකේදී දෙකයි කියලානේ. ඒක හන්ද තමයි මෙහෙම for x greater than 0 කියලා දැම්මේ. එහෙම නැතත් මේක ආවයින් පස්සේ x වලින් වැඩි කරාම ඇති. You may take integrating factor to be මොකද absolute x වලින් වැඩි කරනවා කියන්නේ එක්කෝ ඒක plus x එක වෙලාවකට අනිත් වෙලාවට minus x. අපි බලමු මේක අරගෙන minus x වලින් වැඩි කරලා. ඒතර minus මෙතන minus මෙතනත් minus එනවා. ඒ minus කියන්නේ ඒක කැපිලා ගිහලා අර equation එකමයි එන්නේ. ඉතින් මේ integrating factor එකේදී absolute එක આવොත් it's okay to drop the absolute and do it. එහෙම කිව්වහම තේරෙනවද? Integrating factor එක absolute එක આવොත් මොකද absolute value එක derivative එක ගන්න බෑ x equals 0 වලදී. It's a sharp corner නේ. ඒක හන්දයි එහෙම. නැත්තම් you might get into the habit of saying integral of 1 over x is ln x, which is wrong. ln absolute x. Now මේක කැපිලා ගියායින් පස්සේ එන එකේ x positive කියලා ගත්තා නම් ඇති multiply කරන්න. Absolute x වලින් ඕනේ නැහැ. Okay? තේරුණාද? Example එකක් කරමු. Next example, x squared x squared x squared dy over dx අමාරු කියන්නේ ඉතින් අර px වල එකක් තමයි අමාරු වුණා නම් minus x times x minus 2y equals e to the x times x plus 2. E to the x times x plus 2. Make argument balance. How do you? This is also an equation which can be turned into linear first order. මොකද කරන්න ඕනේ ඉස්සෙල්ලාම? dy over dx plus function of x times y equals a function of x. But this x squared is not there in the standard form. Standard form of a first order linear differential equation. That is this now. So this coefficient of this dy over dx should be 1. So divide this by x squared. If you divide it by x squared, the equation becomes dy over dx, since the time is running out. This divided by x squared. Minus. If you divide this by x squared, x capital 1x cancels. You get x minus 2 over x times y equals here e to the x plus 2 divided by x squared. Now, what is p of x? Integrating factor. Integrating factor is e to the integral minus x minus 2 over x dx. dx. Oh. How do you integrate this one? E to the, take minus sign out, integral, then divide. X over x is 1 minus 2 over x dx. Make a karaldi, make amatak karan. How do you do this integral? Minus. This is equal to. So you have to divide and do, otherwise you don't know how to integrate it. No? E to the minus, what is this integral? 1 dx. What is the integral of 1? 1 is x. Then minus 2, yes?
ln absolute x.
ln absolute x. ln absolute x. Now we don't put a constant here. No? When you integrate, you put a constant. No? I didn't explain that. I just took this part. If it is an integral, there should be another constant. So we need only, we don't put the constant here. We need only one integrating factor. Only one IF. One IF. Therefore, C is not needed. C, we can take C to be 0. That is why the constant is not put. That is why the arbitrary, that is why the arbitrary constant is not written. That is why the arbitrary constant, if you put plus c for every c, there is an integrating factor. So just take that to be 0. Okay, just one integrating factor is what is needed. So when you get absolute value of x also, we can take x, because we only need one integrating factor. That is another way to explain it. Okay, so we are going to multiply an equation by the integrating factor. So whether it is a +1 or -1, after multiplication, minus sign disappears. Okay, now here still absolute x is there. We'll see what happens after simplification. We multiply this out. E to the minus x plus 2 ln absolute x minus sign. Now, this is equal to e to the minus x, properties of exponents, minus x times e to the second, 2 ln absolute x here. Even if you drop absolute there, it's okay. This is equal to e to the minus x. Here, of course, we get e to the absolute x, take 2 there. E to the ln absolute x squared. So you get e to the minus x, e and ln cancels, e to the minus x. Here, this is absolute x squared. So we only take x. Here, of course, it's square, so no issue. You don't have to write any condition. X squared is the integrating factor. So that was difficult in the sense that integration is a difficult one. Not difficult, but it's some work to simplify it to a nice form to multiply this equation with. We call this equation 1. Equation 1. So what is the integrating factor? E to the minus x, x squared. Now take 1 and multiply it by the integrating factor. Take 1 and multiply it by the integrating factor. In order to do this, let us write what is 1. Equation 1 is, I'll write equation 1 first. Dy over dx equals minus x minus 2 over x, not equals. This is the equation. Dy over dx minus x minus 2 over xy equals that. I'll write 1. I want to multiply 1 by, what is 1? 1, let me repeat. 1 is dy over dx minus x minus 2 over x times y equals e to the x plus 2. Be patient, things will work out. Now this is the integrating factor. Multiply 1 by integrating factor. 1 by, now multiply 1 by if. If. Oh, the part of gives you multiply. Integrating factor is e to the minus x, x squared. So e to the minus x, x squared dy over dx minus, if you multiply this by e to the minus x, x squared, or you can straight away say, when this happens, this side is d over dx integrating factor times y. But to explain, e minus x, x squared. When you multiply this by e minus x, x squared, 1x cancels. So e minus x, x minus 2. When you multiply this by e to the minus x, x squared, these two terms cancel. You get just x plus 2. Look, here also you have e to the x, x to the minus 2. When you multiply this by e to the minus x, this e to the x times e to the minus x is 1. X squared divided by x squared, then those two also cancel. Therefore, what is left is x plus 2. So the entire equation, so left-hand side now, left-hand side is d over dx integrating. Don't even check. You can straight away write d over dx integrating factor times y. That is e to the minus x, x squared times y equals x plus 2. left hand side is always integrating factor times y, the derivative of if times y. Now integrate. What do you get? Integrate both sides. Here, this side e to the minus x squared y is equal to integral x plus 2 dx. This side is easy. E minus x squared y is equal to integral of this is integral of x is x squared over 2 plus integral of 2 is 2x, and then you have to put plus c.
Excuse me, sir.
Yes,
Sir, e to the minus x squared y කියලා ගත්ත විදිය තේරෙනවා.
මෙතන නේද? මෙතනද? මේ හැමතිස්සෙම අපි අර තියරි එකේදී කිව්වේ මොකද්ද? When you take the equation in the form dy over dx minus px equals qx. ඒ form එකෙන් තියෙන equation එකක් අරගෙන integrating factor එක හොයලා integrating factor එක ආවේ e to the minus x squared නේ. integrating factor එකෙන් ඒ equation එක වැඩි කරාම හැමතිස්සෙම මේ left hand side එකේ එන්නේ integrate d over dx integrating factor times y කියලාමයි. theory එකේදී එහෙම වෙච්ච හන්ද මෙතන අපි check කරන්න ඕනෙත් නෑ. ඇත්තටම මේක අරගෙන මේකෙන් වැඩි කරනකොටම
ඒකේ answer එක ගත්ත විදිහ අර x minus 2 එක
මෙතන තියෙන x minus 2 එක නැති වෙච්ච විදිහද? මෙතන තව පොඩි එකක් missing නේද? x minus 2 මෙතන y missing. ඒක කමන්නේ මොකද හේතුව මේක වැඩි කරාම හැමතිස්සෙම මේක තමයි එන්නේ. මෙතන y එක missing. Thank you for me asking the question. මට හරියටම තේරුන්නේ නැහැ ආට මොකද්ද කියලා explain කරන්න ඕනේ කියලා.
සර් එතන e to the minus x ගුණ කරනවනේ x වලින් ආය minus 2 ගෙන ගුණ කරලා එතන answer කරන් දෙන්නේ.
මේ පේලියෙන් මේක ආපු හැටි නේද අහන්නේ. හරිද?
ඊට පහළ එක ආපු හැටි.
ඊට පහළ එක ආපු හැටි. ඒක තමයි අර මේ තියෙන්නේ මේ integrating factor. මේ තියෙන්නේ මොකද්ද? integrating factor වරක් dy over dx. හරි? මෙතන අපි පෙන්වුවා නේද? මේ equation එක අරගෙන integrating factor එකෙන් වැඩි කරාම integrating factor කියන්නේ ix කියලානේ අපි ගත්තේ එතන. මේක වැඩි කරාම එන equation එක තියෙනවානේ. මේක නෙන්නේ එතකොට dy over dx මෙතන තිබ්බේ pxy qx නේ. දැන් මුළු එකම integrating factor එකෙන් වැඩි කරනවා. වැඩි කරාම මේ මෙතන තියෙන ටික තමයි හැමතිස්සෙම d over dx ix වෙන්නේ. ඒක මෙන්න මෙතන පෙන්නුවේ. එතකොට after you multiply by the integrating factor, the standard form left hand side always becomes this. මේක theory එකේම පෙන්නුවානේ. හැමතිස්සෙම මෙතන මේ පැත්ත වෙන්නේ integrating factor times y. එක බලන්නකො මේක වරක් මේකේ derivative එක. ix times derivative of y plus y times derivative of ix. ඒක නේද product rule එක තියෙන්නේ. uv dash කියන්නේ uv dash plus vu dash. derivatives වල product rule එක දාපුවාම එතන දැන් මට ඕනේ ix වල derivative එක. ix වල derivative එක කියන්නේ ix px. එතකොට මෙතන තියෙන්නේ ix px. එතකොට අර ස්ටෑන්ඩඩ් ෆෝම් එක අරගෙන ඉන්ටිග්‍රේටිංగ్ ෆැක්ටර් එක වැඩි කරාම හැමතිස්සෙම චෙක් කරන්න ඕනෙත් නෑ. දකුණු පැත්තේ වම් පැත්තේ එන්නේ left hand side you get integrating factor times y. එහා පැත්තේ qx වල i වලින් ix වලින් වැඩි වෙනවා. ඊට පස්සේ ඉන්ටිග්‍රේට් කරන්න තියෙන එක තමයි ඉන්ටිග්‍රේට් කරපු ගමන් මේක නැතුව යනවා මේක සමානයි. දැන් මේ ඒ විදිහට දැන් බලන්නකො. මේ තියෙන මොකද්ද?
හරි සර් තේරෙනවා.
ඔව් මේ තියෙන ඉන්ටිග්‍රේට්. දැන් මෙතන වෙලාව නාස්ති වෙනවා මේක අරගෙන මේක එනවා කියලා පෙන්වන්න යන්නේ. එහෙම අවශ්‍ය නැහැ කියලා කියන්නේ. Tamil speaking students, there is no need to check whether this is equal to this because that was done in the theory and it will happen always. Then අහපුවන්ද ආයිසරයක් කියන්නම් but you don't need to check. Take the equation, multiply by the integrating factor. Left hand side always becomes this. Right hand side x plus 2. Kalin tibba complicated එකක්. When you multiply by e to the minus x squared, these two terms kill each other. So kill the terms that we multiply with, we are leaving us with x plus 2. Then මේක මම check කරන්න නැතුව කෙලින්ම ලියනවා integrating factor times y කියලා. අතෙන්දී ඔප්පු කරපු හන්ද since we proved it there. Now if you are in doubt, අපි බලමු use the product rule. This one times y, and derivative of y, that is this term. E to the minus x squared එක එකක් හැටියට ගන්න. E to the minus x squared dy over dx. And the derivative e to the minus x square, e to the minus x squared dy over dx, that is this term. Plus y times derivative of this. Make a derivative එක ගත්තාම එන්නේ මේක. මෙතන ඉඳන් මෙතෙන්ට. product rule එක දාන්න එපා යායිම. It looks complicated. This is just x squared minus 2x. Make a derivative එක ගත්තොත් එහෙම ex times e to the minus x times derivative of x squared 2x plus x squared times derivative of e to the minus x is e to the minus x times minus 1. That simplifies to this. තේරුණාද? තේරුණා නේද? එතකොට ඔයාලට විෂය එක තිබ්බේ මේක කොහොමද මෙහෙම වුනේ කියලා නේද?
ඔව් සර්.
ඔව් ඒක අර තියරි එකෙන් තමයි ගත්තේ. මෙතනදී බැලුවත් අපරාධ වේලාව නාස්ති කිරීමක් වෙන්නේ. It's just a waste of time to trying to see whether this is equal to this because in the theory we proved it is always that. So ඒ step එක කෙලින්ම යන්න පුළුවන්. මේ පැත්ත check කර කර ඉන්න ඕනේ නැහැ. ඒක theory එකෙන් ආවා. From the theory. When you multiply by the integrating factor, the given equation, left hand side is always derivative of d over dx of integrating factor times y. ඒක prove කරා මේ කොහොමද this one times derivative of that is ix times dy over dx plus y times derivative of ix. Derivative of ix is ix px. ඒක තමයි මෙතන ඔප්පු කරන්නේ. මෙතන ඔප්පු කරේ derivative of ix is equal to ix px. So then this is always equal to that. So after multiplying the equation by the integrating factor, we always get d over dx integrating factor times y. එහෙම මතක තියාගන්න. Remember it that way. Okay, after multiplication by the integrating factor, no matter how complicated it looks here, it will be integrating factor times y, d over dx. After you have this step, you integrate both sides. No, integral of the derivative, just the function equals integral of the other side. Don't forget to put dx also. It was integrate. Now to find what time is it? Oh, 9:05. Yes. Oh, do you have a lecture now? තියෙනවද lecture එක?
ඔව් සර් තියෙනවා 9:00ට.
9:00ට right. එතකොට මෙතෙන්ට ආවා. දැන් මේකෙන් y හොයන්න පුළුවන් නේ. You divide by e to the minus x squared. Or even you leaving it like this is also okay. Anybody can find y in terms of x. No, after integration is complete, you can leave the answer. Don't make it even more complicated. Anybody wanting y can find y, or you have to divide this whole thing divided by e to the minus x squared. දැන් මේක මම ලේසි ගානක් දෙන්නම් දැම්මම ඒ කියන්නේ අනිත් ලෙක්චර් එක ඉවර වුණාම ඕගොල්ලෝ ප්‍රැක්ටිස් කරන්න. I will send you the tutorial also on differential equations. ඊට පස්සේ mid semester කියලා I will give you a take home assignment. copy කරන්න එපා. මේ කියලා දෙන්නම් මේ linear algebra first order differential equation. ඉස්සෙල්ලා ටියුට් එක දීලා ටියුට් එකේ ඩෙඩ්ලයින් එක ඉවර වුණායින් පස්සේ නිකන් one day වගේ තමයි දෙන්නේ මේ අපි ඒක අද ඉඳලා 2 weeks වලින් අද ඉඳලා 2 weeks වලින් mid semester එකක් take home assignment එකක් දෙන්නේ. එතකොට note එක බලලා තනියෙන් හදාන්න. නැත්නම් end semester එකට ගියාම හිර වෙනවනේ කොහොමද? හරි? එහෙම කමක් නැහැ නේද? කමක් නැහැ නේද? It's take home one, so no pressure. මේ ප්‍රශ්නේ so for linear differential equations do this problem. No, similar to what we have done. පරිස්සමෙන් කරලා බලන්නකො procedure එක. x squared dy over dx plus 4xy equals 1 plus x squared. බැරි නම් මම අනිත් සැරේ කරන්නම්. this is homework. දැන් තව එකක් තියෙනවා 9. හතයි මම ඊළඟ equation එක මට තව විනාඩි 4ක් විතර ගන්නම්. Fifth form is known as Bernoulli equation. N-O-U, Bernoulli. Pronounce කරන්නේ Bernoulli, double L-I. මෙතන U අකුරක් තියෙනවා. B-E-R-N-O-U-L-L-I. Bernoulli physics සමාන කරලා ඇති. Bernoulli equation. These are equations of the form and equation of the form and equation of the form dy over dx plus p of x y මෙතන නිකන් බැලුවොත් එහෙම මොකක් වගේද පේන්නේ dy over dx plus px times y equals qx. This is a first order linear differential equation. Bernoulli equation is a first order linear differential equation. On the left hand side, left hand side is the same, but the right hand side is this times y to the n. So the Bernoulli එක මේක නැත්නම් if this term is not there, Bernoulli equation is a linear first order linear differential equation. We learned how to solve it using integrating factor method. So if the n is equal to 0, this is not there. Okay, so Bernoulli equation it's if y to the power 0 is 1, therefore it becomes a linear differential equation. If n is equal to 1, then pxy qxy. If you take this term to the other side, you get you get q of x y minus pxy. That is qx minus px times y. It's a separable equation. You can separate the variables and solve the equation. So here, when we say Bernoulli equation, we don't need to take n equal to 0 is just n equal to 0 is first
Okay.
order. N equals 0 is first order linear differential. Linear DE. So we know how to solve it. If n is equal to 1, it is if it is a first order linear differential equation. That is for n equals 0. If n equals 1, it is, if n is equal to 1, it is a separable DE. So A අවස්ථාවේදී අපි විසඳන්න දන්නවා. So when we say Bernoulli equation, we take n to be so we take n to be not equal to 0, 1. N to be not equal to 0, 1. Okay? එහෙම අරගෙන ඉතින් solve කරන හැටි අනිත් දවසේ කියලා දෙන්න. දැන් කරන්න ගියොත් එහෙම වෙලාව මදි වෙනවා. 9:12 න. You have another lecture at 9:30 නේද? So we'll continue on next Wednesday. Okay? So there are linear algebra වලට වඩා මෙතන වෙනස තියෙන්නේ you need integration. Integration by parts උත් සමහරක් වෙලාවට ඕන වෙන්න පුළුවන් ගන්නට. So you need to know integration well. Okay? මේ integration ටික හදා බලලා හරි ගස්ස ගන්න. I will send a tutorial with some easy problems at the beginning. හැමෝටම කරන්න පුළුවන් වෙන අනිත් ඒවා චුට්ටක් විතර කල්පනා කරලා බලන්න. Okay? And stop there. මොනවාරි ප්‍රශ්න තියෙනවද ඔයගොල්ලන්ට? Oh. Yes, any lectures don't give up with the අතහැරලා lecture එක මේකෙන් බලලා කරනවට වඩා වෙනස්. It's very different by being at the live session versus just looking at the video. කියන්න පුළුවන් ඔක්කොම කියනවා වීඩියෝ එකේ තියෙනවනේ කියලා. No, it's not like that. There is a difference. I want you to attend lectures. Right. I'll stop there. See you next Wednesday.
Thank you, sir.
You are welcome.
Thank you.
You are welcome. You are welcome.
Thank you, sir.
You are welcome. Bye. Stay safe, okay?